A common problem type faced on the power PE is something like this. We have a delta source connected to a load. And we'd be asked something like, what is the power being used by the load in the example circuit? The circuit is three-phase in this instance, and when faced with the three-phase problems, it's not always obvious how and where to apply the root 3 in the formulas. At times, the root 3 is not involved, and at times it is. When it is involved, its position, either in the numerator or the denominator, can change based upon certain factors given in the problem. This may seem very, very simple to you as a practicing engineer studying for the PE. In fact, most engineering books don't even really talk about this. Even though it may seem obvious and easy, it isn't. It's very, very simple to flub this particular question based upon where the root 3 goes. And you can mess that up very quickly. In fact, the PE often questions you on this specific knowledge, and the question types that we'll put to you will require you to know this very, very specifically. So you need to know, make sure you know both how and why the root 3 works. Now, in practical engineering situations, there are rules of thumb that we all use. But on the test, you'll need to be sure how these rules of thumb apply to a given situation. So even though you think, I know you think right now, you know when to use the root 3, you have to know not just when, but why and how it works if you want to pass this test. Remember, we're not teaching you general engineering. We don't want you to have to learn all of the basics and all of the advanced knowledge for general engineering. What we're teaching you here is specifically how to pass the PE. And this is a subject that is important to pass the PE. Okay, so back to the problem. In this three-phase circuit, what is the power being consumed by the load? In order to identify this for how the root 3 is going to apply, we need to see three factors. We need to consider three factors. The first factor is going to be the source configuration. And we have two options. Either it's going to be Y or delta. The second factor is going to be the load. Is the load single phase or is it three phase? And if it is three phase, is it Y or is it delta? The final of the three factors is, what is the given information regarding line versus phase? And what I mean by that is simply, is it phase voltage that you're given in the problem, or is it line voltage? Is it line to line, line to phase? Any combination that exists there. But it's important to identify and understand those factors. So those are the three that we need to identify first in the problem before we're able to place the root 3 appropriately in our formulas. Now let's identify the factors for our particular situation. The first factor, the source, as we've said before, is delta. So we have a delta source for number 1. Our second factor is the load. We have a single-phase load. It's a single-phase load on a three-phase system. It's interesting to note that simply because we are on a three-phase system, we're not necessarily required to use the root 3. It's something to keep in mind. Our third factor is, what are the givens? Let's supply these with a 25 amp phase current and a 480 volt line voltage. Now recall, we are solving for power, so our equation is P equals VI. Since it's a delta source with no neutral, both the line and the phase voltage are 4. And so there's no need in the third factor to distinguish between the phase voltage or the line voltage. They all equal the same thing. We have just plain voltage. Having completed our understanding of the voltage in this particular problem, we now move to the current in the equation to find power of the equals VI. If the current were given as the line current and not the phase current, the root 3 would not be involved in the calculation. It really would be just a simple multiplication of voltage and current to find the power through the load. The standard P equals VI. But the current given is phase current, so we need to convert it to the line current. So we're moving from the phase current over to the line current. And it is here that we see a very important principle that you need to remember. When the line and phase values are different, moving from phase to line requires multiplying by root 3. Moving from line to phase requires dividing by root 3. This is because the line value is greater than the phase value. So just to repeat that really quickly, when moving from phase to line, we multiply by root 3. We're going from small to large. When moving from line to phase, we divide by root 3. We're moving from large to small. So with the line voltage being given, we convert the phase current to line current. That means we multiply 25 amps by root 3, and it will give us this line current, which is 43.3 amps. So now we have our equation all lined up and filled out to find power at the load. We have P equals VI. Our V voltage is 480 line voltage, and our current at the line is 43.3. So P equals 480 times 43.3, which in the end yields 20.8 kVA. A vital principle, as we just said, illustrated by this particular problem type involving root 3 calculations, is when moving from phase to line and line to phase, there is a protocol of multiplying or dividing by root 3. Phase to line requires multiplying, line to phase requires dividing. Moving from small to large is the multiplication, and large to small is the division.